All right, welcome everyone. Thanks for coming. I'm James Ward. I'm a platform evangelist at Salesforce. So today we're going to talk about how to do machine learning with PredictionIO and do that with some Salesforce data. So how many people here would say they're a data scientist? Okay, I'm not one either, so this is great. We'll get along really well. So I just started doing some machine learning stuff, and PredictionIO makes it really easy. So yeah, we're all at the same level, and we'll go through this. So as I'm sure you've seen 100 times this week, this is our forward-looking statement, and please don't make any purchasing decisions based on what you hear in my presentation. Here's our agenda for today. So we're going to talk a little bit about what machine learning is. I'll give you a little demo, and then we'll talk about the architecture of the app. Go through some code. We'll get to see some code, and hopefully I can explain it to you, and it'll make sense. And then talk about how we do deployment. So that's our agenda. If you have questions, feel free to ask them throughout. I'll try to save some time for at the end for questions, but always feel free to shoot up your hand and ask a question. Yeah, question. Yes, I will post this on the chatter feed. Thank you. Yeah. Any other questions? Okay. Okay, so this is my non-data scientist look at what machine learning is. So essentially what we're doing with machine learning is we're doing pattern recognition, and we're doing that via ones and zeros. Our brain has a bit different mechanism. It doesn't use ones and zeros to do pattern recognition, but our computers think in terms of ones and zeros, and so somehow we need to tell through ones and zeros how to recognize patterns. So in the very, very, very basic sense, if we have some data and then we have some logic structure that is looking at that data and making decisions based on what it sees in that data, then what we can get out of that is a decision or a prediction or a categorization. And that, to me, is essentially what machine learning is at the core. But that's how we kind of been doing machine learning for a long time, as far as I can tell. But what we're doing now is something that's a little bit more complex and works better. So what we do is we take some data, and then we have an algorithm, usually some statistical algorithm, and there's a couple different types of machine learning. But what we're essentially doing is applying an algorithm to this. If you've heard the term deep learning, that's a bit different. That's more trying to simulate the way that our brain learns. So actually, like the algorithm isn't a statistical algorithm. It's actually trying to work like our brain does, like a neural network does, and try to learn in that way. So, but either way, we're going to take the data, we're going to apply an algorithm to it, and we're going to create a model. And that model is a statistical model that then we can ask questions to that statistical model and say, okay, based on your model of this data that you've derived using some math from this data, now give me a prediction back or give me a categorization. A prediction is usually in terms of some type of rating, saying give me the probability that this is true or that this matches your data set, your model, that sort of thing. So that's my very basic non-data scientist look at what machine learning is. Any questions on that? Yeah, go ahead.
Regression analysis is a very simple form to predict.
Yep.
That is a kind of the machine learning, or this is outside?
Yeah, regression analysis. Yeah, so I would consider regression analysis definitely a type of machine learning for sure. Yep, because it is essentially recognizing patterns via ones and zeros, via some kind of logic. Yeah, good question. Okay, so that's my very, very basic intro to what machine learning is. So let's talk about some use cases. Where would we use this? So one place, we're at a Salesforce conference, so CRM data is near to many of us. So here's an example of what we could use machine learning for, is to rate leads with how likely they are to close. So let's think about that for a little bit. If we needed to do this without a machine, we'd have to look back at historical data. So we'd look at some factors. We'd say like, okay, just looking at this data, we want to know like how many times did the user come to our website? Did they take this next step and sign up to a newsletter? So we'd look at these sorts of things, and then we'd be able to see, okay, we've looked at this data, and we've found that if people go to the website 50 times and then they sign up for the newsletter, that they have a 20% chance of converting, right? Whereas if they don't sign up for the newsletter, then they only have a 5% chance. And so we can build up these models in our mind, and we all do this all the time because we're really good at recognizing patterns. And so what we're doing with machine learning is just taking those types of algorithms that we have come up with, the pattern matching that we can come up with our brain, and trying to fit that into a program. And so there's a lot of different statistical models that we can apply to be able to accomplish those sorts of things. So some other use cases here. So categorize this text as offensive or not. So again, to do that, we need some data set. We need to learn from a data set what is offensive. So we need some way to tell it, here's the offensive things, here's the non-offensive things. And that's what we do. That's how our brains will categorize something as offensive or not. And so we're taking the sample data, we're creating a model, and then we can run we can ask that model for a prediction, or for a categorization in this case. Another one that's pretty common is recommend products based on what I've liked. So I've liked some products, and now we want to get some recommendations back, and we'll talk more about this use case in a little bit. Another one is detect anomalies in credit card purchase behavior. So again, what's the data that we would need to do that? We'd want to know, based on past transactions, here's some typical spending patterns different merchants and types of merchants that I spend with, and merchants that I regularly spend with, and amounts that I regularly spend. So with machine learning, we're just getting the computer to do what our brain is already doing when we do that type of pattern matching. So those are some common use cases. To break it down a little bit more, let's say we want to do product recommendations. So what we're going to do is take a bunch of users and what they like, and then we're going to create a statistical model around that. And here's actually the part of the equation for how we would do product prediction or product recommendation. So we're going to take all those likes, we're going to use a mathematical equation, a statistical equation, to give us a model, and then we can ask that model that's been created from all those likes. Okay, if I liked this one and this person liked this other, also liked that thing, then we have some commonality between us, and so now I can make a prediction about what else you will like, right? And that's tied up in that equation that I don't really understand, but someone came up with, and now we can just use it. So that's what kind of looks like for doing product recommendations. So I want to dive into a demonstration to show you what this actually could look like. But before I do that, is there any questions on kind of the basics of machine learning or comments? Okay. All right. So what I'm going to do is show you a demonstration of something called Dreamhouse. And Dreamhouse is a demo application that we've put together. It's all down. There's a bunch of demo stations down in the developer forest using it. So this is kind of like our reference application for the Salesforce platform, and has a lot of different pieces. Let me just show you the site where you can find out more about that. So if you go to dreamhouseapp.io, then you can go through here, you can learn how to install the basic part of it, and then there's all sorts of different pieces of the Dreamhouse application. You might have seen that in the developer keynote today. So here's the PredictionIO one, and so you can go find out more information about what I'm going to be showing you. And if you want to actually get this up and running in your own environment, then there's instructions there for how to do that. So that's Dreamhouse. Let me actually show you the demo app here. So it looks a little weird because it was created for a phone, so it looks kind of weird on a large device here. But in the Dreamhouse application, what I can do is I can go browse through some properties. So we can see I'm browsing through properties that are for sale in Boston, and I can go select one of these and find out the information, the details about that property. So kind of simple. The basis of Dreamhouse is a basic CRUD application. The data for this actually lives in Salesforce, but we'll talk more about the technology and the architecture in a little bit. But I'm actually running this on Heroku, so we'll talk more about how that works in a little bit. OK, so I've got these properties, and I can go in and favorite a property, right? So that's great. Now that I've favorited a property, what's actually happening is that favorite data gets stored back into Salesforce. So let me show you the broker experience. So if I'm a broker, I want to be able to see who's actually favorited different properties, and then I could create campaigns around them, use all the great Salesforce features around that data. So let's go launch the Dreamhouse application here. And what we'll see is that there is a favorites object. And so here's my favorites. Let's go take a look at this through the all view. There we go. So we can see that a favorite is really just an association between a user and a property. I'm not sure why that one doesn't have a user. So that's what a favorite is. It's stored in Salesforce so that now we can go, as a broker, I can go look at all the favorites on specific properties and that sort of thing. So it's great to have that data in Salesforce, but what we'd really like to do is be able to use this favorite data, do machine learning on this data, and then expose that out to the end users of the app in the web UI for Dreamhouse that I was just showing you. So if you look down here at this list, you'll see that there's a favorite for 32 Prince Street by DC SWT and one by Fubar. So two different users have favorited the same property. So what that's now saying is that if I'm one of these users and I go to my recommendations, I'm going to get recommendations that are similar to this other user's favorites. So with two users, not super interesting data set, really simple. But you can imagine now if we have tens of thousands, hundreds of thousands of users that are all favoriting things, now we can create some really interesting models from that data. So, but we're going to stick with this simple data set. And if we go back into the app and I go to recommendations, what we'll see is now it's recommending to me some other properties that I may be interested in. And those should be the properties that that other user has also liked, because now that we've both favorited the same property, we have something in common. And so now it should be recommending to me the other properties that that user has liked. And so these actually come back as a scored. So we could actually expose these in terms of, oh, you would most like this one because you have the most users in common with you that have also liked this one. So that would be exposed through the algorithm that we're going to be using. We'll be taking a look at the code for that in a little bit. But in this case, we're just saying, hey, here's all your recommendations. So we're kind of throwing out the actual scoring of the recommendations for this example. But yeah, so that's our recommendations in the Dreamhouse app. OK, so that's our quick demo on Dreamhouse. Any questions about the demo before we go into architecture and code? OK, so before we talk about architecture, we need to go through and define some of the terms that I've been throwing around and talk about what those actually are. So first, PredictionIO. PredictionIO is an open source machine learning server. It's part of Einstein. And so this is a technology that allows you to build machine learning algorithms and run those algorithms and make predictions based on what those algorithms and models have determined. So PredictionIO, it's open source with Apache, and that's what I'm using here for this demo. Heroku is a cloud platform for building and deploying applications, and that's part of the Salesforce App Cloud family. So that's where I'm running the Dreamhouse application and running PredictionIO. Heroku Postgres is a relational database that is managed by Heroku. So it's in the cloud and gives me a relational database that now I can use. So the Dreamhouse application, the web application that we saw, the one where we saw the properties and the favorites and the recommendations, all that stuff, that's actually running against a Postgres database. So that's actually going to a Heroku Postgres database to get that data out. But you may have noticed the data is in Salesforce, and so there's a technology called Heroku Connect that now synchronizes data from Salesforce to that Heroku Postgres database and synchronizes it back, so it's bidirectional, optionally bidirectional synchronization of data. And so now I have this scalable relational database that I can use for my front-end web and mobile applications, and it's read-write both ways. So I can read the data from Salesforce through that database. I can write the data into that database, and it then writes to Salesforce. So that's what I'm doing to actually synchronize the data between Salesforce and the Postgres database. You don't necessarily have to use that. You could use the REST APIs against Salesforce. But the nice thing about using it is that's a really scalable, really low latency way to have this data exposed out to my web and mobile applications for my end users. OK, the next one is Apache Spark. Any people done Spark development in here? OK, couple, good. So Apache Spark, if you're doing any kind of big data processing, Apache Spark has become almost the de facto standard for how you do that type of big data processing. So traditionally, it was used for batch processing. So what you would do is you would take a massive data set, gigs, terabytes of data, and you would, in Apache Spark, through a cluster of machines, you would be able to take that data and do some analysis on that data. Mostly done by data scientists who would be writing these models, be writing the analysis code that would then be going across these large data sets. And the traditional way to do data analysis in Spark is something called MapReduce you might be familiar with. Essentially what that's doing is it's saying, get all this data, transform it in some way, and then reduce it in some way. So an example of that is, let's say I have a database with gigabytes of view events. So every time a user views one of my properties, I want to store that into some big data store. But then I want to reduce that down to, OK, how many times in a day did somebody view this property? So MapReduce, if I wanted to do that in a batch way, that's what traditionally Apache Spark is used for. So then there's an add-on module to Apache Spark called Spark ML, and this is machine learning libraries on top of Apache Spark. So what they've done is some really smart data scientists have wrapped up all these algorithms that are pretty typical in data science, in machine learning, wrapped them up and made them available as a library. So now somebody like me who knows nothing about statistical analysis can actually just use those APIs and not have to understand all the math that's going on underneath that. So that's actually what I'm using for the algorithm that we'll get into in a little bit. So those are the main pieces of the puzzle for what we've used to build this example. Any questions about any of those pieces, or did I miss any pieces? Yeah?
Quick question. So for Heroku Connect, are you pretty much in the app just connecting to Postgres, and then the way you connect to Salesforce is just by the layer above, so you're not touching Salesforce?
That's exactly right. So from my web and mobile application that's end user facing, I am just talking to the Heroku Postgres database, and then Heroku Connect is doing the synchronization behind the scenes to Salesforce. So my app actually knows nothing about Salesforce. Yeah, and I think that's becoming a pretty typical architecture for those end user facing types of applications. Not limited to that, but pretty typical now. Yeah, question. Yeah, great question. So PredictionIO is kind of this glue that glues together a bunch of different pieces and helps me actually create something that can be trained, something that can save the model, so it actually persists the model, and then allows me to use that model, recall that model later, and then ask that model for predictions. So remember the machine learning model that I talked about earlier, where we're creating a model from some data, then we're going to ask it for prediction. So PredictionIO is kind of giving us a framework that wires all those different pieces together. There's another piece of PredictionIO that I'm not actually using in this example, which is what's called an event server. And the event server in PredictionIO, let's say that I did want to take view events. So every time somebody viewed a property in the Dreamhouse application, I wanted to use view events instead of favorite events. The view events, I probably wouldn't want to store all those in Salesforce, right? Just wouldn't make sense. I may want to store aggregates of view, so like how many times something was viewed, but I don't want to store the raw view events. Whereas with PredictionIO's event server that I'm not using here but could, I could actually feed every single view event into PredictionIO and then run my queries against all those view events. So that would be the place where I would use the event server part of PredictionIO, but I'm not using it for this particular example. Did that help with that? And when I get into the code of this, it'll make a little bit more sense for how all this stuff kind of comes together. Did that help, though? OK. Any other questions before we move on? OK, great. So those are the pieces of our puzzle. So let's talk about what actually happens in that Dreamhouse machine learning application. So when I favorited the property in the Dreamhouse app, that stored into the Heroku Postgres database was then synchronized to Salesforce so that we had that data in Salesforce. Okay? So then I've got my favorites data in Salesforce. So the way that we use PredictionIO is we need to tell it at some point to learn from that data. So we'll see the code in a minute for how we actually do the learning. But usually what we're going to do is have some periodic interval or something where we're telling the engine to go learn from this data set. So it's not automatically like learning continually, because that would be pretty resource intensive, especially on a large data set. What we're doing is on some interval, hourly, daily, whatever, we're learning from the data that's there, and we're creating a model. Then we save that model. Okay, so that's what one thing that PredictionIO is doing for me is it's saving that model. And then we can now ask PredictionIO, use that model that you've created, use the most recent one, and give me a prediction back. So in this case, we're saying, give me recommendations. The way that we ask it is we say, for this user, give me back what other things are similar. So what other users have liked that are similar to what I've liked is essentially what we're asking it for. There is another way that we could actually use this model is we could give it a property and say, give me back similar properties. So it's actually just kind of going at that model from different dimensions. We can go at it from the user dimension or from the property dimension. In this case, for recommendations, I want to ask it on behalf of a particular user. OK, so that's our architecture for how we built this. Questions on the architecture? Yep. So technically, PredictionIO can use different data stores for where it actually stores its events, the events that we're not using in this example, and where it stores the model. And so in this case, we're actually using the same Heroku Postgres database that I'm using with Heroku Connect. I'm using that same Postgres database to store the model in. So what happens is when I run the training algorithm, it actually creates the model, and then we serialize that model and store it into that Heroku Postgres database. And then when the web app, there's a REST API for PredictionIO, when that runs, it goes and fetches that model from that Heroku Postgres database, pulls it into memory essentially, and now I can ask that model for predictions. Did that answer that question? OK, cool. Other questions? Yeah, go ahead.
Maybe not right now, but maybe later on. Can you speak of how you decide what platform you use to run PredictionIO?
Yeah, so PredictionIO is open source, and it could run anywhere. I'm running it on Heroku because that gives me access to Heroku Connect and Heroku Postgres and those sorts of things. So that's where I chose to run it. But PredictionIO is open source, and you could really run it anywhere. So how you decide that, kind of up to you. Yeah, I love Heroku and use it for everything, but yeah, it's you don't have to do it that way.
So you could potentially run PredictionIO on Heroku and Einstein on Salesforce and compare the two?
So yeah, good question. So PredictionIO today wouldn't run natively on Salesforce. It's a JVM application, and so you have to run it somewhere that you can run JVM applications. So that's why Heroku is a great choice for this. So you couldn't, for instance, run PredictionIO inside of Apex or something. So yeah, so anywhere you can run a JVM, you can run PredictionIO. Does that help with that?
Right. I'm trying to compare that to Einstein.
So this is part of the Einstein platform. It's just like the more developer-oriented part of Einstein. So I mentioned lead scoring as one of the use cases. So Salesforce has built some higher level machine learning stuff where developers don't have to write any code. No one has to write any code. It's just built to Einstein, built into Salesforce. And so lead scoring is one of those examples where I should never have to go build my own lead scoring because Salesforce has already built that for me. And so I'm not sure what they built that on top of, if they used PredictionIO or if they used SparkML or something else. But so they've already built that for you, so you don't have to build that particular type of machine learning. So this is really more useful when you have some kind of custom machine learning that you want to do, something that's not already been built into the Salesforce platform. Yeah, thanks for pointing that out. Yeah, question?
Can it handle both structured and unstructured data?
So it depends on the algorithm that you're using with PredictionIO. And let me actually show you real quick. Here is a really good resource. So if we go to the PredictionIO website, you'll see up here there's this templates gallery. So in the templates gallery, there's all these different templates that you can start with. There's product recommendations, there's lead scoring if you want to do that. So all sorts of different ones. And so what I would do is the use case that I want to do, whether it's structured or unstructured, I would first go look through the template gallery, see if there's already a template for PredictionIO that matches what I'm trying to do. And there probably is, because there's a bunch of them. So I would start there, grab the right template, and I'm pretty sure that PredictionIO supports both structured and unstructured data. So, but yeah, check that out in the template gallery. Yeah, another question.
Strategies to use for bulk applications so that you're not constantly loading that model into memory and then wiping it and loading it?
Yeah, good question. So the way that it actually works with PredictionIO is when I start up my PredictionIO REST endpoint that I'm going to ask for predictions, it loads the model once out of that, and then it's in memory, and now I don't have to reload it again until I restart the application. So yeah, it keeps it in memory. So that is definitely one of the parts of machine learning is if you want to keep that model kind of hot and primed in there, then it requires a lot of memory depending on what your data set is. And so you can sometimes need very large RAM instances of servers in order to handle that. Yeah, one more question. We'll go on.
You've got multiple data sets and models loaded. Are they all in the same Spark context, or are they using different contexts?
Yeah, so they're all in the same Spark context in this case. What I would do if I needed to do that is I would just create different apps on Heroku, each one having its own model and its own Spark context. So yeah, it does definitely use a single Spark context in PredictionIO. Cool, great questions. Okay, sorry, I got to move on, but we'll have some more time for questions in a little bit. Okay, so let's take a look at the code so you can get an idea for how I built this. So there's a couple different parts of an application in PredictionIO. One is the data source. So the data source tells PredictionIO where to actually get the training data from. So you'll see that this is Scala code. I like Scala, but you could write this in, I think they also support Java and Python. So let's go through what's going on here. So I have this class data source, and it has a method read training, and it gives us our Spark context. We're not really using the Spark context here. We use it to actually query the database, but don't particularly need it in this case. So what we're doing is first defining our query. So we're doing a select, and we're selecting from our favorites table. And then we put in some parameters here because it allows us to do partitioning of the query, if that makes sense. In this case, it doesn't really make sense. But so we're doing this select. Then we have a function that's going to get the data, the property __ C field, the user __ C from that favorite, and it's going to put it into an object called favorite. So we're just wrapping that up. And then we create a training data object, and the way that we actually do our query is we're using this data source JDBC RDD, which is a Spark concept, to make a JDBC, a SQL query via JDBC out to our Heroku Postgres database. We're giving it our query, we're giving it our Spark context, which it needs for some reason, and we're giving it our row mapper. So that's it. So now we have our training data. So that's actually doing the query to get the training data out of our database, out of our Heroku Postgres database. And now we have that training data. So the next piece is the algorithm. And this is where it gets more interesting. In the algorithm, we have a train method, and this has a Spark context, and then it has basically the data, the training data that we've prepared for it. And what we want to return is a model. So the model is what's going to be persisted, and then we can use to do predictions on later. So this is why there's two methods in there, a train and a predict, because those are two separate steps, right? So there's some code here that's doing a little bit of munging of data, transforming of data into the right form that SparkML needs it in. But ultimately, here's the interesting part, is we're calling als.train, and we're giving it our ratings, which we transformed our favorites into ratings, and then a couple parameters that have been provided to the algorithm. So that's it. Like all the statistical stuff that is behind this is wrapped up into that one method call where we're doing als.train. So als is the alternating least squares algorithm. So this is provided by SparkML, and there's a whole bunch of math to alternating least squares. But that's what's actually creating this model that now that's taken our favorites data, turned it into the right model that now we can ask it for predictions and recommendations. So that's how we create our model. Now let's look at the predict part of this. So when I go in that app and I go hit that recommendations button, what that's actually doing is making a REST call to the PredictionIO server, which is ultimately calling this predict method here. So what I get in the predict method is this ALS model. So I get the ALS model that was created from the train method. And then I get a query because I need to know what are you looking for? What are you going to ask this model? So the first thing I need to do is do some munging of the user ID. And then what we can do is we go down to this matrix factorization model, which is actually underneath the alternating least squares algorithm. What it essentially produced is a matrix factorization model. So that's the way that it's representing this model, is through this matrix factorization model that I don't really understand how it works. But what's cool is that it provides me this recommend products method. So I give it the user ID and I tell it how many results I want back. And it returns back to me in this case, the other properties that I would be interested in, each with a rating. So that's it. Really just two method calls in SparkML, the ALS train, and then the recommend products. Those are built for me. I just use those, and then I get back my property ratings. You'll see that I'm doing a little bit of transformation on the ratings to get them ordered in the right order there. So that's it. I return a predicted result with those property ratings, and that's what actually comes back through the REST service and as a JSON string, and then I use that JSON string in the web app to display the recommended properties. So that's the nice thing about PredictionIO, is it kind of wraps up all these different pieces together. This code started with one of the templates from the template gallery. So I went to the recommended products template in PredictionIO. So I didn't really have to write much of this code. Most of the code that I write was pulling the data out and then doing a little bit of transformation on that data. You may notice if you looked at these like user string int map, what that's doing is that SparkML, it doesn't, I have string IDs. So I have these string IDs coming from Salesforce. That's my user ID. And SparkML, for some reason, doesn't want string IDs. It wants int IDs. And so I have to transform the string IDs to int IDs. So there was a little bit of mucking around to make that happen. But really, only a couple method calls from SparkML to make all that work. OK, so that's our algorithm. Now, kind of cool part here is that I can write tests against these algorithms. So let me walk through this, because I think this is kind of cool. So when I was working on this, what I did was I created my test and tried to do some test-driven development to actually test this algorithm to see if it was going to give me back what I expected. So here I'm creating 6 favorites. And we'll see that there's product 1 and product 2 and product 3, right? And there's user 1, user 2 has a couple favorites, user 3 has 3 favorites. So a pretty simple model of favorites. And then what I can do is actually train based on that data set, that very small data set. And then I can do my predictions. And I can validate that when I can validate the model that I would expect to be true is actually true. So in this case, we look at, okay, I'm going to ask it for user C1. Give me the recommended products for user C1. So what I want to see is that the P1 product was the highest recommendation, P2 was the second highest recommendation, and P3 was the third highest recommendation. So if we look back at the data set, C1 has liked P1, C2 has also liked P1, and C3 has liked P1. So what that means is that it should be recommending back to me the other products that those other users liked. So if we look at C2 also liked P2, C3 also liked P2, but C3 additionally liked P3. So what that's telling me is that the highest recommended product should be P1 because all three of us like that one, and I'm not filtering out, in this case, the products that I've already favorited, which we could do. But P1 should be the highest recommended product, P2 should be the second highest, and P3 should be the third highest recommended product. Does that make sense, how the commonality of our likes is what's actually driving the algorithm? So I'm actually testing that at the end here, and my test works and is passing, and so sure enough, my algorithm is working as I expected. Okay, so that's most of the code. You can find all that on GitHub. So if you go to that URL, developer.salesforce.com/dreamhouse/PIO, it's all up there, and you can deploy it all in Heroku. So let me give you a quick run through of how I deployed this on Heroku, and then we'll wrap up with some questions. Okay, so first, to deploy, we need to deploy the PredictionIO event server on Heroku and use Heroku Postgres. So again, I'm not actually using that event server, but I still need to deploy it even though I'm not using it in this case. So we deploy that. And we create an app in the event server. So in PredictionIO, there's a concept of an application. So I define an application in the event server. Then I set up Dreamhouse and set up Heroku Connect. Then I deploy my PredictionIO engine, which is the code that you just saw on Heroku. But I need to share the database between those two applications. So there's two different applications for PIO. There's the event server application, and there's the engine application. And I want to share the database between them both. So I do that. And then I train the model. So the way that I train the model is I run a command on Heroku that reads that data out of Heroku Postgres that's coming from Salesforce. And then it reads that, creates the model, persists it back into the database, and then we're ready to ask it for recommendations. So that was the steps. It's a bit involved right now. It's not like a one button click to deploy like a lot of things on Heroku. There's a number of intertwined dependencies, so it's a little bit tricky to set all this up, but the instructions should, in the GitHub repo, should help you get started with that. That's also the same URL as the developer.salesforce.com/dreamhouse1, but simpler form. Okay, we've got a couple minutes for questions. Any questions about anything you've seen? Yeah, go ahead.
Yeah, in case, so for example, this is a use case from Heroku perspective.
Yeah.
We have a Salesforce app, and we want to do some customized machine learning tests.
Yep.
Maybe an opportunity of some other beyond
Yep.
Salesforce business.
Yeah.
Can we potentially use PredictionIO platform? Same thing?
Absolutely. Yeah. There's really nothing that's Heroku specific about PredictionIO. So yeah, you could use PredictionIO, not having anything to do with Heroku against Salesforce data for sure. Yeah, it's just a matter of defining where your data source comes from, whether it's the PredictionIO event server or Salesforce or some combination of the both. Yep. And then yep, that definitely worked. Yeah, question.
So for example, the lead scoring that they have on Einstein, it answers one question. What if you wanted to create another question, like categorization of the developers who look at this? Could you integrate anything to that Einstein?
Probably not directly into that widget, but you definitely, through the Lightning App Builder, can add additional components to any page in Salesforce. So you could certainly create a Lightning component or a Visualforce page that would be the front end for what's the predictions that are coming from PredictionIO. Absolutely, that's something that would totally work. Yep, it's just that your PredictionIO service would have to be running outside of Salesforce. Heroku as one option. Yeah.
So Einstein, which is a platform, embedded into the platform, this did not talk about specifically Einstein, right?
So this is part of Einstein. So Einstein is an umbrella that has a bunch of different pieces. Some of those we saw in Mark's keynote are embedded directly into the Salesforce UI. For the App Cloud, PredictionIO is one piece of Einstein that you can run with the Salesforce platform. Yeah, so it's a bit different than the like CRM-y part of Einstein.
Just to compare it with something like Amazon ML, right, which is a service with the cloud.
Yep.
For machine learning service. Will Einstein ever be something like that for the Salesforce developer ecosystem?
Yeah, it's a good question. I'm not sure what our plans are around that. You can certainly run PredictionIO as a service on Heroku. It's just that there's a little bit of manual work to actually do the deployment today. And yep, you definitely can do it today. You can run it in a managed service on Heroku, and that's what we have today with PredictionIO. I hope we get something more, but today that's where it is. Yeah. Yeah.
Just for clarification then, so in terms of Einstein or anything else that might be available on the CRM platform then, there's nothing that you could, there's no API in Epics at this point for Einstein, is that right?
Not that I'm aware of, but I would. So right now, the developer parts of Einstein, the actual like APIs I can use are like PredictionIO. There's also the prediction learning services and prediction, I think they call it classification services through the MetaMind acquisition. So there's APIs for all that stuff, those parts of machine learning. On Heroku for PredictionIO, on the platform for the MetaMind APIs. Yeah. So, but in terms of like lead scoring, is there an API for lead scoring? Not that I'm aware of. But yeah, that part is just built in as a higher level construct in the Salesforce. Yeah. Okay, I got to wrap up, but I'll be around if you have questions, other questions. So thank you so much for coming. I hope that was useful for you. Thanks.